Okay, so that's my presentation.
So we have 10 minutes. Please go ahead.
Yeah. So process safety in biogas. Sorry for all this trouble, which is because maybe my other laptop is not working well. So my today's topic is process safety in biogas. So I'm a chartered chemical engineer from iChemie. Got 30 years experience in design and commissioning. I worked in different areas in Europe, and I worked in oil and gas, LNG, biogas, fertilizer, ammonia storage, and various other sectors. So this biogas basically presentation I divide into three parts. One is biogas, what it is, and then process safety, and then how we implement the process safety, the biogas assets. So biogas can be produced from raw materials such as waste, green waste, or agriculture waste. It can be produced from animal waste as well, animal droppings, and also from human waste, which is waste. Now, what is biogas? Biogas is typically a combination of methane and carbon dioxide, which is formed by decomposition of organic matter and under the anaerobic conditions, which means it is in absence of oxygen. So basically, the organic matters consist of three parts: carbohydrates, protein, fats, and oil. Sorry. So under anaerobic condition, basically four kinds of reaction which takes place from the organic matter to generation of methane and carbon dioxide, which is basically hydrolysis, acetogenesis, and methanogenesis. So basically in hydrolysis, the complex compound like carbohydrates, fats, and proteins are broken down into simpler chain from polysaccharides to monosaccharides, sugars, fatty acids, amino acids. And then under acetogenesis, basically the acids are formed in form of carbon dioxide, alcohols, acetic acid, and ammonia. So all these acids then combine under methanogenesis bacteria, and methane and carbon dioxide is basically produced. So this is what biogas you get. Typical composition of biogas is methane 55 to 70%, carbon dioxide 30 to 40% normally. You get some S2S because of S2S generating bacteria. You have some ammonia because of protein. You have water coming out from the digester because it's saturated gas. You have some kind of a silicon because in wastewater treatment, when you have shampoos and soaps, so this silicon comes along with this waste. A typical wastewater treatment plant, if you look at it, consists of a primary clarifier, activated sludge, and secondary clarifier. The primary and secondary clarifier sludge, they go through a thickening process, and the thick sludge is injected into the anaerobic digester where the biogas is produced, and this is burned in CHP, which is a combined heat and power cycle, where the electrical energy is being produced. There are other routes as well, gas to grid kind of thing. Now people are talking about bio LNG as well. So there are various sort of methane routes you can go with. What's the beauty of anaerobic digestion is when you got this digested sludge, you can dewater it. The water goes back to the process, and the left out sludge is basically good as a fertilizer. So your nitrogen, which is basically part of the organic matter, gets back again to the soil. Whereas if you compare with the other process, when you're burning like incineration, the nitrogen goes back to nitrogen dioxide, and which is lost, and which is basically caused damage to the environment. So typical biogas process will consist of a digester, clamshell valve, gas bag, waste gas burner, dehumidifier, booster compressor to boost the pressure, silicon filter to get rid of the silicon, and CHP engine. So this is a very broad process flow diagram. There are quite a few more equipment as well, like a pasteurizer and heat exchangers. So now we come back, understanding the what is biogas and system. We come back to process safety management. So process safety management is nothing but it's engineering and management, a blend of engineering and management skill put together to basically eliminate or prevent any kind of hazards such as fire, toxic release, spill, and any kind of a structural failure. The whole idea is to prevent basically loss to the environment, business, and to the human life. What happens when process safety goes wrong? I think we had enough of seen a lot of slides on this, so I'll just go quickly to this. Now, process safety management objective is basically to achieve zero harm and zero incident. And process safety management is not with a completion point, and it's a continuous management system. I think most of the speaker must have spoken same thing about this. It's a moving target, and it needs collection of information, audit, training, communication, procedures, corrective actions, all these things. If you look at broadly the hazard management or process safety management system, it's basically in 4 pillars. I call it commit to process safety, understand hazard and risk, manage the risk, and learn from the experience. So basically the second and third part, which is understand hazard and risk and manage the risk, becomes the most critical aspect. So if you divide broadly in any organization, so it's senior management direction and support it needs, mid-management commitment it needs, and frontline needs for the implementation. So the process management system or process safety management is basically is a complete envelope from top to bottom. And what we did is in one of my process safety management in biogas, we divide the process management into basically design safety, operation safety, and management safety. So in design safety, what we have done is we have done a risk analysis, and this risk analysis is we again decide what are the different aspects in engineering which will give the indication about the process safety risk, and these are the engineering and design barriers, management change, alarm and process control, operational procedures, human factors, maintenance and inspection, safety audits, training, behavior, organization. So everything put together, that's what the risk analysis is all about for an operating asset. To make operating people to understand.
We have 2 minutes.
Yeah, I'll just go very quickly. Then this is all about. We have seen it. What we try to do is we try to compare process safety with a football team, where we have a defined role such as forward, midfield, and defender, and we convert that into design, operate, and maintain. And again, in the design, we got various elements. Operation safety, we got different elements, and maintenance safety, we got different elements. So what we do is each element we do risk assessment, and we define into low, medium, and high risk. And low risk basically, which is within the limits. Medium risk where we can, do some kind of improvement, and high risk is we have to resolve immediately. So once we do that audit, what we get is an Excel output where we can see number of high risk and number of medium risk and low risk for each element. And from this, we can make out what is the percentage design high risk, percentage operate risk, and percentage maintenance risk. And we add all together, we will get the percentage of asset risk. Then we multiply by the age factor, as we know that some of the assets which are old enough or have passed the half-life design, they will be more in terms of maintenance risk. So we put more factor on maintenance, and if the asset is new, less than 2 years, design and operation becomes more critical. So once we do that, then each asset, different asset is being risk rated, and we can present in terms of this building blocks. skyscrapers. So you can see from the red towers, these are basically overall high risk for different assets. You can use this for in your single refinery in terms of your units, at different units, what are the risks. And then once you know the risk, then you can align this with a risk reduction program. So this is the blue, what you see is number of risk reduction activities carried out, and we have reduced the risk. So in terms of conclusion, I can say risk assessment in design, operation, maintenance with percentage high risk provide team-based approach with defined roles. Risk assessment provides clear understanding of safety critical elements. Percentage risk provide more clear picture of asset risk to all stakeholders in the organization. And finally, the percentage risk and asset can be easily aligned to the project funding. So your funding goes in the right where the risks are. So this is what is my work on process safety in biogas. Thank you very much. If you have any questions,